Hi, welcome to this lesson on trigonometry, trigonometric functions, part 1. Let's have a look at question 5. The graphs of f of x, which is given by negative half cos x, and g of x, which is given by sine of x plus 30 degrees, for the interval 0 to 180 degrees, are drawn below. A is the coordinates 130.9 degrees and 0.33, is the approximate point of intersection of the two graphs, given by that coordinate there. Okay, so before we look at the questions, let's just analyze the functions. F of x equals negative half cos x. So cos x is the standard parent function, cos x. And because of the a value being negative a half, that tells us two things, right? First of all, because it's a half, it's a vertical compression. So the graph has sort of been squished downwards by a factor of a half. And furthermore, because it's negative, essentially it would have been reflected across the x-axis. Okay, we can see from the purple graph F, it does look like it's been reflected because cos usually lies in the upper half when drawn. Okay. Also, it tells us that the amplitude, the distance between the turning points and the middle of the graph, is a half. And then for g of x, the only parameter that's being affected is inside the brackets, x plus 30 degrees. So that's a plus p value. That tells us that there's a horizontal shift on the x-axis of the standard parent graph sine x by 30 degrees to the left because of the plus 30. All right, so they want us to write down the period of g. Okay, so g of x equals sine of x plus 30 degrees. So recall the general form as a sine bx plus p plus q. Period is affected by that b value, and because your b value is 1 here, it's 360 degrees, the standard period of the sine x graph, divided by the b value of 1. So the period of g is 360 degrees. Amplitude of f. Okay, so the amplitude of f is always the absolute value of your a value. So absolute just means you take the positive of whatever number is in front of your cos x. So the positive of negative a half is just positive a half. So that's the amplitude. Okay, yeah, they just want you to work out f of 180 minus g of 180. So if we plug in those values, we get negative a half cos of 180 degrees minus sine of 180 degrees plus 30 degrees. Okay, cos of 180, that's a special angle. It's negative 1. So you get negative a half times negative 1. Minus, now sine of 180 plus 30, you could either use compound angle formulae to expand it out, or you could use your cast diagram and reduction formulae. So if you have 30 degrees here, then if I go 180 from there, I end up in the third quadrant. Okay, so it's 30 degrees off the horizontal of 180. So it still remains sine, but because it's in the third quadrant, it's negative. So it becomes negative sine 30 degrees. And then don't forget about that negative that was outside already. So negative a half times negative 1 is positive a half, and negative sine 30 is plus sine 30 degrees. But sine of 30 degrees is a special angle, that's a half. So a half plus a half is 1. Okay, and if we go back to your graph, let's see how this makes geometrical sense. Here's f of 180. Okay, and that was this value here, so 180 degrees. We worked it out to be, sorry, that's g over there. F is here on the purple graph. We worked it out to be a half. And then for g, we worked it out to be negative sine 30, which was negative a half. So that's a half units from here. That's a half units from here. So altogether, the distance is 1 unit. Okay, and that's f of x minus g of x. F of 180 minus g of 180. Use the graphs of f and g to find the values of x such that f of x minus 10 degrees equals g of x minus 10 degrees. All right, so if we go back here, what's actually happening when we do that? Well, f of x minus 10 degrees means you take the entire graph f and you shift it to the right by 10 degrees. So essentially it'd be offset by 10 degrees and it would look something like this. In red there. And then if we did the same thing for the graph G and we offset it by 10 degrees, it would start somewhere there and it would look something like this. Okay, so these are rough drawings. So there'll be a new point of intersection. So what's happened? Every single x value of f and g has simultaneously moved 10 degrees to the right. So it would make logical sense that the point A also gets moved 10 degrees to the right. So that would be this point of intersection here, the new, let's say A prime, would be 140.9 degrees and with the same y value because only the x values were shifted. So that's using the graph and geometrical logic. We would then say then that x minus 10 degrees, okay, this input here, when are the two graphs actually equal to each other, f of x equals g of x, that is when x is equal to 130.9 degrees. So we want this input here, both these inputs, to be 130.9 degrees because then they are equal. So we have x minus 10 degrees equals 130.9 degrees. And if I add 10 to both sides, we get 140.9 degrees. That's using the algebraic approach. Now look at that. Your algebraic approach and your geometrical logic gave you the same solution. Okay, so it's nice when you can think about it in different ways and get the same answer. Lastly, you want to use the graphs of f and g and find the values of x such that root 3 sine x plus cos x is greater than or equals to 1. Okay, so initially this looks quite random, but it says use the graphs. So the graphs are probably an indicator that we need to use this. So that means we can probably rewrite this expression somehow given these two functions here. Okay, so first of all, there is a cos x term, which I see, so I'm happy. And sine is x plus 30 degrees, but here we only have sine x. So that kind of leads us as a clue that maybe we should expand this out using compound angles. Okay, so g of x is sine of x plus 30 degrees. So if I expand that out, that's sine x cos 30 degrees plus cos x times sine of 30 degrees. Okay, and that's going to equal to cos of 30 is root 3 over 2 times sine x, and sine of 30 is a half times cos x. Now this looks promising. There's a root 3 sine x and there's a cos x. We've got a root 3 sine x, but there's a divide by 2 here. And we've got a cos x, but that's also divided by 2. So if we take this original expression and divide both sides by 2, okay, the inequality won't change because 2 is positive, then we get root 3 over 2 sine x plus a half cos x must be greater than or equals to a half, okay, dividing both sides by 2. But this here is exactly g of x. So now we've simplified the problem towards the graph. G of x greater than or equals to 2. So if I go back to the graph now, okay, so let's just clear this up so we can see the graph better. Okay, so now, here's the two graphs here. G of x is this graph in black here, and you want it when it's greater than a half. Okay, so I want to notice something. What happens at this coordinate here, 0 degrees, when I plug it into G? Well, it's going to be 0 degrees plus 30, which is 30 degrees, and sine of 30 degrees is a half. So I already know here's half, y equals a half. So if I just extend this line out a bit, yeah, okay, half is greater than a third, it's 0.5, that makes sense. Okay, you see it's going to hit another point here somewhere, where it's also going to have so it's going to have an x coordinate and a y value of a half. So between 0 degrees and that x coordinate there, the graph here is lying above a half, or it's equal to a half. So that is the desired interval that we want. So we just need to find when is this graph equal to a half again. So let's go back down here. So g of x, we want to know when it's a half. So we're solving the equation sine of x plus 30 degrees equals a half. So this is a trigonometric equation. Okay, so in our cast diagram, positive a half, so sine is positive in the first and the second quadrants. So therefore the reference angle will be sine inverse of a half, which is 30 degrees. So in the first quadrant rather, we're going to have x plus 30 degrees, the entire angle, must equal 30 degrees plus k times 360, period of sine. So if I subtract 30 degrees on both sides, I get k times 360 degrees. And then in the second quadrant, I must have the angle x plus 30 degrees equals 180 minus the reference, which is 150, plus k times 360 degrees. So subtracting 30 degrees on both sides, I get 120 degrees plus k times 360. Okay, so now I just need to plug k values and check that it's within this domain 0 to 180. So in the first quadrant, when k is 0, I get x equals 0 degrees, which is that first one we saw when we were drawing our graph. And that is in that interval. Taking any other k value as an integer will be outside that given domain. Then for the second quadrant, if I put k equals 0, I get 120 degrees, which is inside the domain. And then every other k value will be outside the domain. So there's only 2 points, 0 degrees and 120 degrees. Okay, so let's go back here. So this x value is 120 degrees. So therefore the solution is g of x is greater than or equals to a half. So therefore g of x is greater than or equals to a half if and only if x is between 0 degrees and 120 degrees inclusive. Okay, so that is how we would do these types of questions. I'll see you in the next one.